Good morning, year four. I hope you're all doing great. I hope you had a lovely weekend. Today we're going to start with our final practice worksheet found in your resource packs. We will be answering 4 pages of them today. And then we're going to continue in our live session, inshallah, on Wednesday. So let's start together. So this is page 95 in your resource pack. Question 1 says, Abdul has some stacking masses. So as you can see, the boy named Abdul has some masses that he is stacking on each other. He puts one mass on the standing tower. So this is the standing tower, and he starts to put one of those masses to the tower, and afterwards he uses a forcimeter, as you can see, to pull the tower. So he has this is called the stacking tower, and he adds a mass to this stacking tower. And by the way, guys, the mass has a hole in the middle of it that will make him be able to put it in the stacking tower. And then he tries to pull the stacking tower with the added mass using the forcimeter. Draw an arrow on the picture below to show the direction of this force. So he is pulling the tower. So this means that the direction of the force is towards the boy Abdul, because he's pulling it towards himself. Question B says, Abdul measures the force needed to pull the tower. He notes the forcimeter reading each time he adds a mass to the tower. So he has the tower here. He pulls it using a forcimeter when he added only one mass, and the reading of the forcimeter was 0.30, which means and of course we measure it using Newton because it's the forcimeter, so we measure it with the measuring unit Newton. Then he adds one more mass to the previous one, and he pulls again, and then he measures the reading that he got from the forcimeter, which is 0.45, and then he adds one more mass, and then he pulls it with the forcimeter and records it, and it's 0.60. Then he adds one more, pull it with the forcimeter, 0.75 is the reading, and then he adds the final one, then he pulls it again, and the final result or the final reading on the forcimeter was 0.90 newtons. Look at the notes of Abdul's results and then describe what Abdul's notes tell him about the number of the masses and the size of the forcimeter needed to pull them. So what is the relation between the number of masses he is stacking to the stacking tower and the size of the force, or how much force he is exerting in order to pull the stacking tower with the masses? You will find that the more he adds masses to the stacking tower, the more he needs to apply force, or the more he needs to pull with a larger force in order for the stacking tower to move. So this is the relationship between both readings. As he increases the number of masses, the force size will increase. Sorry. Now question C in page 96, it says Abdul puts his results into this table. So here's the table that he's recording his results in, but he makes a mistake. Now let's make a quick look over. So he wrote the number of masses in the right order, 1, 2, 3, 4, 5 masses. But when he recorded the force meter reading, you will find that it does not make sense. When he added only one mass, it was 0.90 Newton. When he added two masses, it was 0.75, which is less than when he added only one mass. And then we will notice that the readings are actually decreasing. They are becoming lower the more he adds mass. So what is the mistake that in Abdul's table, the mistake that he did is he inverted, or he put the force meter reading in the wrong order. They should be increasing just like the number of masses. We are adding masses, so this means that the force that we are exerting are supposed to be getting more. So he put the force meter reading in the wrong order. The next question says Abdul notices his mistakes. He corrects his table. Then he says, I wonder if I made any mistakes when I did my test. What should he do to check if he made any mistakes in his test? So we agreed before that in order to have a fair test, or in order to make sure that your test is right, we have to make the test several times so that we know that our test is accurate. So this is what he should do. He should repeat the test several times and take several readings to make sure that his readings and the steps of the experiment are correct. Next is page 97, question number 2, A. It says, some children are riding skateboards. It is easy to get hurt riding a skateboard, of course. Look at the picture below of Jane and Lewis. Then list two pieces of safety equipment that the children have used. If you look over here, they are wearing something over their heads. This is the helmets, of course, and they also are putting on some knee pads. So those two pieces of safety equipments are really important if you are skateboarding, or you're using your roller blades, whatever you're doing. If you are on any type of rollers, you have to make sure that you are wearing all of your safety equipments. Question B says Jane and Lewis are facing in the same direction. So let's assume that both of them are looking this way, in the same direction. They are on level ground. So they are both on the same level, and they are not moving. So again, both of them are looking this way, and they are on the same level ground, and they are not moving yet. Jane gently pushes Lewis on his skateboard. He moves forward. As Lewis moves, Jane also moves. Let me just point that Jane and Lewis, both of them are on their skateboards. She is not standing on the floor. She is on her skateboards while she was pushing Lewis. So I want you to imagine if you are on blades, roller blades, or you're on a skateboard, you have rollers under you, and you're pushing someone forward. You will be moving backwards. So this is the answer. In which direction do Jane and her skateboard move when she pushes Lewis? It's like a reaction. She is pushing him forward, and on the other hand, she is getting backwards because of her push. So this is what will happen. She is going to move backward. Jane and Lewis go back to the same starting places. Jane gives Lewis a bigger push on his skateboard. They both move faster this time. What happens to the distance that Lewis travels on the second push compared to the first push? So we know that if we increase the amount of force while we're pushing something, of course it's going to move a larger distance. So this is the answer. He will move for a longer distance. The second question says, what happens to the distance that Jane travels on the second push compared to the first push? The same will happen. She is, as we said, if she's pushing someone forward, the roller blades that she is on will move backwards, so this will make her move backwards. And since she is pushing with a specific force, she is going to be pulled, or she's going to move backwards with the same exact force. So this means that we increase the force, so she's going to move for a longer distance too. The last question says, Dave goes over a jump on his skateboard. When he jumps, he stays in the air for a short time. What force makes him return to the ground? I think this is a very easy question. Of course, gravity will pull him back to the earth, or to the ground. This is it for today, guys. This is your homework, page 92. It's a reading homework, so you're going to use your closer look book. You have to read pages 575 to 581 in order to be able to answer those questions, and it's due Wednesday. We're going to correct it together in our live session. Until then, I hope you're doing great, all of you, and see you soon, inshallah. Bye bye.